In this 9th lesson of the Basic Algebra in Full series, we are going to learn how to find x. And if you are wondering why this is just coming now, here is your answer. To be able to find the value of x or any variable, you need to have mastered two sets of skills. The first is that you must be able to perform basic operations in algebra, such as addition, subtraction, multiplication, division, powers. This is exactly what lessons 1 to 8 cover, and that's why we spent time trying to master them. The second is that you must be able to apply mathematical tactics or tricks, which we will learn in this lesson. If you are able to combine these two skills, you will be able to find x or any variable. As usual, this lesson is structured from basic to advanced. Feel free to jump to the section you need. Let's begin. If you are asked to find the value of x in this expression 2x plus 5, the answer is simple. You cannot, because x has no direction. If you now include equal to say 13, then it becomes possible to find the value of x. Why is this so? It is so because x is like someone who has lost his way and comes to you for direction. If the person doesn't know where he's going to, how are you going to find exactly what direction to give? If there is no end point, then there is no process. This is the reason why it is impossible to find the value of a variable or x in an expression. It must be an equation or something we call inequalities, which we will look at in the next series. But for now, you just have to understand that the value of a variable can only be discovered if you are dealing with an equation, not an expression. Because we are just still learning and we are in the Basic Algebra in Full series, we are going to deal with just one variable in an equation. When we get to the next series, Intermediate Algebra in Full, we can start dealing with two variables. But for now, we are sticking with a linear equation in just one variable. The first step to finding what x or any variable is in an equation is understanding the endpoints. What do I mean? What I mean is that the final answer must be x equal to something. It is now that something you want to find. This understanding is very, very important because it helps you go through the processes, the correct mathematical processes to get that answer. So what are these processes? The processes will involve disconnecting this x from this 2 and this plus 5 and pushing all of them away, either to the other side and then leaving only x on one side. So what I'm trying to say in essence is that the first step to finding the value of a variable in an equation is to have at the back of your mind that what you want to achieve is to have just that variable standing alone on one side of the equation and every other thing on the other side. So how do we do this? We will employ the things we talked about at the beginning, those two sets of skills. So the first thing we'll do for this example is to move this plus 5 to the other side. Remember our lesson 2. So if we do that, this will give us 2x is equal to 13 minus 5. 2x is equal to 13 minus 5 is 8. So that is already decongesting that left side for us, leaving just 2 attached to x. Now the next thing we'll do is to find a way to take 2 off x. Now you notice that 2 is multiplying x, which makes it a term. 2x is a term. Now to dissociate 2 from x, it means that you have to divide 2x by 2. That's the only way 2 will go off x. And because we are dealing with mathematics, anything you do to one side and do to the other side, you are mathematically correct. So if we are going to divide 2x by 2, then we have to also divide the other side of the equation by 2. This is one of the mathematical tactics or tricks I was talking about. This will give us 2x over 2 is equal to 8 over 2. 2, we cancel the 2. Then 2 here 1, 2 here 4. So the final answer becomes x is equal to 4. Now you see how we are able to get x by applying the basic operations we've learned from lessons 1 to 8 and the mathematical tactics I'm talking about. This is a simple, straightforward way to find x. Sometimes it may not be as straightforward as this. What if the variable appears more than once in the equation? Let's look at this example. Now look at this example. 2x minus 5 is equal to 15 minus 3x. Now we notice that the term that has x is both on the left and on the right. Our process doesn't change. Same thing. Find a way to move all the terms that have x to one side and every other one to the other side. We learnt this skill when we did lesson 2, collecting like terms. So this gives us 2x plus 3x, that is if we move this to this side, is equal to 15 plus 5. So 2x plus 3x is 5x is equal to 15 plus 5 is 20. If we do what we did before, we want to separate 5 and x. So to do that, 5 is multiplying x. So the reasonable thing to do will be to divide by 5. And if we divide by 5 here, we'll also divide by 5 on this side. So that gives us 5 will cancel 5, and then 5 here 1, 5 here 4. So x is equal to 4. So as many times as the variable appears on either side of the equation, your aim is to pull all the terms with that variable together. That is to collect all the terms. Remember, you can only collect like terms if all the operators are from the same family. This is from lesson 2. You see the reason why we spent time learning those basic operations in algebra. Now look at this scenario here. Let me use it to explain something so that you understand that everything you learned must not be thrown away. Mathematics is connected. Now look at this same thing, 5x, but this time around it is 5x equals 25 over 3, then plus 7. Now, if you wanted to do divided by 5 in order to isolate x or free x, that is correct. But on this side, you want to do divided by 5. You cannot just go ahead and put divided by 5 here. You are going to make a mathematical error. Why? Because this divided by 5 you've written here is standing on its own. Whereas what you're actually trying to do is to divide the entire side by 5. Since you divided this entire left-hand side by 5, you must divide the entire right-hand side by 5, not just putting divided by 5 in isolation. So what I'm trying to say is that the appropriate way you would write this will be 5x divided by 5, then equal to 25 over 3 plus 7, all divided by 5, or the best way to do it, which we talked about in the last lesson, divided by 5 this way using the fraction or the division bar. This tells us that everything on that right hand side is divided by 5. This is exactly the proper mathematical way to do it. I'm introducing this now so that you always remember that when you are dealing with operators from different families, you must be very, very clear and distinct. We explained this in the previous lesson, order of operations. Different family operators behave differently. So when the operators are not from the same family, you must be distinct and clear what you actually mean. You cannot just put divided by 5 that way. You have to put it in bracket and divide the entire thing by 5 to show us that it is the entire thing that is divided by 5. Now, let us go to another situation or scenario. What if x is entangled in a fraction? How do you dissociate that x from that fraction? It's basically the same thing. Now look at this example. 5y over 3 is equal to 5. Same thing we've done, we are going to do again. The variable y is being multiplied by 5 and being divided by 3. So if you wanted to isolate y, all you need to do is do the opposite, that is the sibling operator. So since 5 is multiplying y, you have to divide by 5. And then since 3 is dividing y, you have to multiply by 3. This combination is the same thing as 3 over 5. That is multiplied by 3 divided by 5. So what we are saying is that on this side, we'll say times 3 over 5. And then we'll repeat the same thing on this side, times 3 over 5. So that this 3 we cancel this 3, and then this 5 will cancel this 5. We will now have y isolated here. Then whatever is here, we can calculate it. 5 cancels 5 here. We are left with 3. So y is equal to 3. But there is a faster and probably more efficient way it is done in most secondary schools or high schools all over the world. And that is the concept of cross multiplication. Now, the cross multiplication concept is simply saying that if we have two fractions on either side of the equal to, we can cross them this way. That's what it means, cross multiply, such that the denominator of this one on this side multiplies the numerator of the one on the other side. The numerator of this one multiplies the denominator of this. So this will now give us 5y times 1, that is this times this, is equal to 3 times 5, that is this times this. So that now gives us 5y times 1 is 5y, 3 times 5 is 15. Then if we use the same thing we did before, divide both sides by 5, this now gives us y is equal to 3. You see, you get the same answer. So cross multiplication is another mathematical tactics you can use. Instead of trying to isolate the numerator and denominator, just cross multiply. We are going to be using cross multiplication a lot as we go forward because it's easier and gives us less headaches. Now look at this example showing us that x can also be entangled in a square root or a root generally. So this is square root of 5x is equal to 5. In such a case, you want to remove the root first. We've been saying this from the previous lessons that whenever you see roots, the roots must go. Now, what is the way to remove this square root? Simple. By squaring it. If you square whatever is here, the square will cancel the roots. So that's exactly what you do. And since we are squaring here, we will also square this side. So that now gives us square of this and then 5 squared. So if we square this, the square will cancel the roots, and then we have 5x is equal to 5 squared, which is 25. Then if we do the same thing, x will be 25 divided by 5, and that is 5. So you see, the whole idea of finding x or finding any variable is to use the inverse of whatever it is that variable is involved in. If the variable is stuck in a root, then you find the square. If the variable is multiplying another number in its term, then you simply divide by that same number. If the variable is dividing a number, then you simply multiply by that number. That is as easy as that. This is the mathematical trick or tactics we are talking about. I know we said we are going to stick with one variable, but I'm not putting this because we want to find the value of both a and b. I'm putting it because I'm introducing a concept that is familiar to most students who may be watching this and be wondering, where is this topic? The subject of the formula, or the subject of a formula, or rearranging a formula. When you want to rearrange a formula, it's exactly the same principle as trying to find x or y or any variable. What does it mean to make something the subject of a formula, or what does it mean to arrange a formula? To make something the subject of the formula simply means you want that thing to say it is equal to something. So what we are saying is that in this example, a is equal to 2 plus b. A is the subject of the formula here because a is standing on its own. So the subject of the formula simply means that that thing is standing on its own and is pointing to every other thing that is involved in that equation. So if you are asked in this question to make b the subject of the formula, what they are simply telling you to do is to make this b equal to something based on this equation. So how do we do it? Same thing as like finding what x or y is. The only difference now is that we won't get a definite value as an answer, but we are going to now get a new structure for the formula. So what do? We have to find a way to isolate b. To do that, because we prefer writing from left to right, let us mirror this equation and write it as 2 plus b is equal to a, so that we know that we are writing left to right. Now, the connection between 2 and b is just plus. So, what do? We move the 2 to this side, and then it becomes b is equal to a minus 2. Remember, it becomes minus 2. Reference is lesson 2. And that becomes the answer. So now, b is the subject of the formula. Let us take another example of subject of the formula or rearranging a formula before we now take examples. Now look at this example. 5b is equal to 10n. If you are asked to make n the subject of the formula, again, let us mirror the equation. Let us rewrite it to be 10n is equal to 5b, so that we are writing from left to right. Since it is n, we want to make subject of the formula. Now, the only thing attaching to n is 10, and 10 is multiplying it. So to get rid of the 10, we just divide by 10. And if we are dividing by 10 on this side, we have to divide by 10 on the other side. So that now gives us 10, we cancel 10. n is equal to 5 here 1, 5 here 2. N is equal to B over 2. And that's the answer. It could be more complicated than this, but we are just using this to show the framework of how the answer should be. This is the basic principle by which you are going to find the value of any variable, or rearrange a formula, or make a variable the subject of a formula. Now let us take examples to make everything clear and sink. Now look at this first example. 7x minus 4 is equal to 10. We want to find x. So we move this minus 4 to the other side to start making space for x alone. So this gives us 7x is equal to 10 plus 4, which is 14. Then we divide both sides by 7 to give us x is equal to 14 over 7. Obviously, this is 7x over 7. 7 will cancel 7. Then 7 here 1, 7 here 2. So x is equal to 2. And that's the answer. Let's take another example. Now look at this example. 3 is multiplying the bracket of 2x minus 5, then plus 4 is equal to 2x plus 9. Now, as we've been saying throughout this series, whenever you see the brackets, you have to take off the brackets to make the equation easier on the eyes and to even know what next to do. So we are going to expand the brackets first based on lesson 6 where we did removing brackets. So this gives us 6x minus 15 plus 4 is equal to 2x plus 9. Next, we see that all the operators here are siblings, so it makes things easy for us. So we just collect like terms. 6x minus 2x is equal to 9 plus 15 minus 4. If you wanted, you could simplify minus 15 plus 4 before moving it to the other side. It doesn't really matter. So this now gives us 6x minus 2x is 4x is equal to 9 plus 15 is 24. 24 minus 4 is 20. So we divide both sides by 4 to take away the 4 that is bounding x. If we do that, 4 here 1, 4 here 1, 4 here 1, 4 here 5. So the final answer is that x is equal to 5. If you wanted to test if your answer is correct, if you replace x with 5 here and solve it, what you get will be the same on either side. But we won't do that now. Let's not waste time in this video. You can do it on your own and let me know in the comment section if you got the same answer. Now look at this example. X over 4 plus 2 is equal to x over 3 minus 1. Now again, all the operators are siblings, so let's collect like terms. So this gives us x over 4 minus x over 3. Remember, there's a plus here. When you bring it to this side, it becomes minus, is equal to minus 1 minus 2. If you recall the lesson on simplifying algebraic fractions, LCM of 4 and 3 is 12. 12 divided by 4 is 3. 3 times x is 3x. Minus 12 divided by 3 is 4. 4 times x is 4x. Equal to minus 1 minus 2 is minus 3. If we simplify further, 3x minus 4x is minus x. So minus x over 12 is equal to minus 3. And if we use the cross multiplication we talked about, this will now give us minus x times 1, which is minus x, is equal to 12 times minus 3, which is minus 36. And because we have minus minus, we want to cancel the minus on either side. Minus x is the same thing as minus 1x. So if you want to take away the minus 1, we just divide both sides by minus 1. And if we divide both sides by minus 1, minus 1 cancels minus 1 to give us x is equal to, the minus here will cancel the minus here to just give us x is equal to 36. And that is the answer. If we want to do a quick check here, as I said, if we replace this x with 36 and replace this x with 36, 36 divided by 4 is 9. 9 plus 2 is 11. So we have 11 on this side. Then 36 divided by 3 here is 12. 12 minus 1 is 11. As you can see, 11, 11 on either side. So the answer is correct. Now look at this example about subject of the formula. It says make C the subject of the formula if f is equal to 32 plus 9c over 5. Now remember what we said. The first thing we are going to do, what are we trying to make the subject of the formula, or what are we trying to find its value? C. Look at the C here. Is entangled with 9 and 5 in a fraction combination. So what is the first thing we will do? We have to move this C, or whatever it is, entangled with to the left hand side, and then move every other thing to the right hand side. Then we can now find a way to cut off all the other things that are strongly attached to C. Now, because I know if I move this 9C over 5 to this side, the plus becomes minus, and I don't want minus. I don't want anything that has to do with C to have minus. So what I will do is I will mirror this equation first, rewrite it so that I'll make sure that the term that has the C is on the left first. So we have 32 plus 9C over 5 is equal to F. If we start taking off all the things that are attached to C, we have to move this 32 first because it's the easiest to move. We move 32 to this side. That now gives us 9C over 5 is equal to F minus 32. Now we have the opportunity to cross multiply so that we can take off the fraction, and that's exactly what we'll do. This is F minus 32 over 1. So if we cross multiply, this will now give us 9C times 1, which is 9C, is equal to 5 times F minus 32. Now, I wouldn't just write 5 times F minus 32. I will definitely get a mathematical error here. This is why I explained at the beginning that whenever you are doing something to a whole side, make sure you indicate it clearly that you are doing it to the whole side using brackets. This is the reason why we did a special lesson on brackets. So the appropriate way to write this will be 5 is multiplying F minus 32, because F minus 32 is the whole thing on that side. 5 is not just multiplying only F. So if you say 5 times F minus 32 alone, you will be wrong. You have to put it in bracket. 5 is multiplying the entire thing. That's why the F minus 32 will be in brackets. To now make the C stand on its own, it's just 9 that is preventing us from achieving our goal. So what do we do with the 9? We divide both sides by 9 to take 9 off. So if we divide both sides by 9 here, this over 9, this over 9, this now gives us 9, we cancel 9. C is equal to 5 into F minus 32 all over 9. Or if you love to simplify everything you see, you can go ahead to expand the brackets and say C is equal to 5 times F is 5F minus 5 times 32 is 160 over 9. This is an appropriate answer, or the previous one we also did is an appropriate answer. If you don't want it expanded, you can leave it that way. It is still correct. So that is the answer. So you see that the subject of the formula, or rearranging a formula, is exactly the same process as trying to find the value of the variable. Now look at this example. All the operators are siblings, so we are free to collect like terms. So let us pull all the x to the left hand side, all the terms that have x to the left hand side. So this gives us 3x minus 5x. That's all. So we move all the other terms to the right hand side. So we are starting with the one that is already there, which is minus root 50. Then we move this one next, minus 2 root 18. Then we move this one next, plus root 8. You remember that the signs change when they cross the equal to. I don't need to start explaining all the things we've done in the previous lesson so that we don't waste time. So simplifying further, 3x minus 5x gives us minus 2x equal to. Now this is where we fall back to what we learnt in lesson 5 powers when we talked about prime factorization. So we are going to break down the numbers in these roots to their prime factors and see if we can pull out some numbers out of the roots. And remember, we said we may not remember how the prime factors will align for that number, so we can just pick any number we can remember. So this gives us, for now I know that 50 is the same thing as 25 times 2. So that's exactly what I'll write. Root 25 times 2 minus 2 root 18 is the same thing as 9 times 2, then plus 8 is the same thing as 4 times 2. Now from what we see, we know that the square root of 25 is 5, the square root of 9 is 3, and the square root of 4 is 2. So it makes our life easy. So if we pull out all those roots, we will have root 2 left in all the roots on the right. So this now gives us minus 2x is equal to minus 5 root 2 That is if the root 25 becomes 5 by coming out of the root. Same thing here, 9 will become 3 when it comes out of the root. So this gives us that 3 multiplied by this 2 will give us 6. So 6 root 2 plus same thing here, 4 becomes 2 when it leaves the root. So 2 root 2. This now gives us minus 2x is equal to, now if you recall the lesson on powers, lesson 5, when we discussed roots and surds, we said that roots behave like variables. So we can have like roots and unlike roots, or like surds and unlike surds. So in the same way, we know that this is root 2 in all these terms. So now they are behaving like variables. So we now have to add and subtract them as if they are variables. We are going to assume that this root 2 is a letter like x. So this gives us minus 5 minus 6 is minus 11. Then minus 11 plus 2 is minus 9. So this now gives us minus 9 root 2. Remember, we said we pick just one copy of the variable or of the roots. That's why we are getting this. We now want to get rid of this minus 2 so that we have just x. And what do? We divide both sides by minus 2. If we divide both sides by minus 2 we cancel minus 2 to leave just x here. Then what do we have here? Minus, we cancel minus 2. Now give us 9 over 2 root 2. Or more appropriately, you can say 9 root 2 over 2. And that becomes the final answer for x. Now let's take one more, the final example, before we look at the try exercises. Now for this one, as you can see, there are brackets and we want to take away the brackets first to make the equation easier for us to solve and see what we are doing. So we use the distributive law for these ones. So this gives us 2x plus 2 root 18 over 3 minus, there is nothing to expand here, so we'll just put it like that, x minus root 8 over 4 equal to, same thing on this side, x plus root 32 over 6, then plus 1. On this left hand side, we are going to start gradually. We won't move this fraction yet to this side, even though it has x, because we want to decongest this side first, the left hand side. So we try to simplify these two fractions to get just one fraction. So that's what we'll do. The LCM of 3 and 4 is 12. 12 divided by 3 is 4. 4 times this gives us 4 into 2x plus 2 root 18. Then minus 12 divided by 4 is 3. 3 times this gives us 3 into x minus root 8 equal to x plus root 32 over 6 plus 1. Now if we apply the distributive law to this and this on this left hand side, it gives us 8x plus 8 root 18 minus 3x plus 3 root 8. Remember the lesson on removing brackets, lesson 6. If you are not clear on how we expanded these brackets, go back and watch that lesson. Over 12 is equal to x plus root 32 over 6 plus 1. Now let me mention here that you cannot cross multiply in case people want to cross multiply, because you have plus 1 here. You only cross multiply if you have just one fraction standing alone with nothing else on that side. So cross multiplication will not work here yet. So what we will do now is to simplify this numerator further to reduce the number of terms we can see so that it will be easier to simplify. So we collect like terms there. It gives us 8x minus 3x plus 8 root 18 plus 3 root 8 over 12 is equal to x plus root 32 over 6 plus 1. So this now gives us 8x minus 3x is 5x plus 8 root 18 is the same thing as 9 times 2 plus 3 root 8 is the same thing as 4 times 2 over 12 is equal to x plus root 32 over 6 plus 1. As we did previously, we know that root 9 is 3 and root 4 is 2. So we pull them out of the root and we have root 2 left in each of those terms. So this gives us 5x plus this 8 times the 3 that comes out gives us 24 root 2 plus this 3 times the 2 that comes out gives us 6 root 2 over 12 is equal to x plus, we know that 32 is the same thing as 16 times 2. So this gives us root 16 times 2 over 6 plus 1. This now becomes 5x. Same thing we did, because this is root 2 and this is root 2. They are now like surds or like roots. So this gives us plus 24 plus 6 is 30. So this is 30 root 2 over 12 is equal to x plus root 16 is 4. So the 4 comes out of the roots to now become 4 root 2 over 6 plus 1. Now, this is the simplest we can go on either side. So what we will now do, we can now pull all the terms with x to one side. There's 5x here and there's x here. So we are going to move this x plus 4 root 2 over 6 to the left hand side so that we'll have all the terms that have x on the left hand side. So this now gives us 5x plus 30 root 2 over 12 minus, remember this entire term has a plus here, so when it moves to this side it becomes minus, so minus x plus 4 root 2 over 6 is equal to 1. That is this one here. So now we find the LCM again. LCM of 12 and 6 is 12. So 12 divided by 12 is 1. 1 times this gives us the same thing. 5x plus 30 root 2 minus 12 divided by 6 is 2. 2 times this, 2 into x plus 4 root 2, all equal to 1. Now, we can use cross multiply to take this 12 away. So this is 1 over 1. If we cross multiply, this 1 multiplies this, and this 12 multiplies this 1. So that now gives us 5x plus 30 root 2. If we expand this bracket with the minus 2 here, it gives us minus 2x minus 8 root 2. That is, if minus 2 multiplies this 4 root 2 is equal to 12. Again, all the operators are siblings, so we are not afraid to collect like terms. So if we collect like terms and simplify, this gives us 5x minus 2x is 3x, then plus 30 root 2 minus 8 root 2 is equal to 12. Again, root 2, so these are like roots or like surds. So this gives us 3x, 30 minus 8 is 22. So this gives us plus 22 root 2 is equal to 12. Then 3x is equal to 12 minus 22 root 2. If we now want to isolate x finally to get the value of x, we divide both sides by 3. So if we divide both sides by 3, 3 will cancel 3 to now give us x is equal to 12 minus 22 root 2 over 3. And that becomes the answer. Or if you want to simplify it further from what we said when we discussed algebraic fractions, we said this 3 can divide this even if the operator here is a different family, provided the 3 divides each of them individually. So what you are saying is that we can write this as 12 over 3 minus 22 root 2 over 3. Unlike if this was multiplication where the 3 can only operate with one of the terms. If it is minus or plus, the 3 has to operate them individually. So this can now give us 12 over 3 is 4. So 4 minus 22 root 2 over 3. So this is also an appropriate answer. Here are the try exercises. As usual, check the channel for the solutions after you've tried it, of course. Visit our website mathinfull.com for so many more exercises to make your skills stronger. Our next lesson is going to be the last lesson for this series, which is word problems and real applications of basic algebra. So it's a wrap on today's lesson, how to find x in a linear equation in one variable, lesson 9. Keep studying, and remember, in mathematics, it's all connected.